Welcome back to AI Security Explained, Episode 4. Today, we're shifting the lens away from the prompt and onto something quieter and honestly more dangerous. The stuff your AI trusts, the documents it retrieves, the base models it inherits from, the dependencies pulled in at build time. When any of that gets poisoned, the AI doesn't know it's lying to you, and neither do your users. And here's the uncomfortable truth. You didn't build most of your AI app. The base model, someone else trained it. The documents it retrieves, you probably didn't write or vet them. The plugins and dependencies, rarely audited line by line. Poison any one of those, and the AI gets compromised without an attacker ever touching your code. The attack surface has shifted. It's baked in upstream, long before a user types a single prompt. Trust the source, not just the user. So let's name the two threats we're really dealing with. Reg poisoning is when someone slips malicious content into the documents your AI pulls in at query time. The model behaves normally, but the data it's reading has been tampered with. Supply chain risk lives one layer deeper: a compromised base model, a poisoned dataset, a backdoored library or plugin you built your whole stack on top of. Different entry points, same root cause. A trusted source quietly goes bad. Before we go further, let's make sure RAG itself is clear, because it's where most teams meet this problem first. Retrieval augmented generation is how you get an AI to answer from your data without retraining it. You stash documents in a vector database, pull the relevant chunks when a question comes in, and drop them straight into the prompt as context. Store, search, inject, answer. It's the default enterprise pattern right now. And notice what it really means. On every single query, your model is reading outside text it didn't see during training. So here's how that outside text gets weaponized. An attacker quietly plants a document, could be a wiki page, a PDF, a public repo, with hidden instructions buried inside, and waits for your indexer to pick it up. Eventually, a user's question semantically matches that poison chunk. Retrieval grabs it, and it slides into the prompt wearing the badge of trusted context. From there, the model just obeys. It's the same indirect prompt injection we covered in Episode 1. Only this time, you delivered it yourself through your own knowledge base. So where does this poison content actually slip in from? 4 main doorways: public web content, pages, reviews, wikis that strangers can edit at will, user-uploaded files dropped straight into your retrieval pipeline by customers you don't fully vet, shared or scraped datasets you inherited but never audited line by line. And the quietest one, compromised internal docs, where an insider or a breach edits a source you already trust. The rule is simple. If you index it, someone out there can shape it. Treat every ingested document as untrusted by default. So how do we actually defend that knowledge base? 4 moves working together. First, vet what comes in, sanitize and review documents before they ever hit your index. Second, when you retrieve text, treat it as data, never as instructions. Label it, isolate it, keep it in its lane. Third, filter retrieval by permission, so a query only pulls what this specific user is allowed to see. And fourth, track provenance, know exactly where every chunk came from, and flag the sketchy origins. The mindset shift is the whole point. RAG content is untrusted input that just happens to live in your database. Defend it like you'd defend a user prompt. Now zoom out from RAG for a moment, because there's a bigger pattern here. Every AI app you ship is sitting on a stack you didn't fully build, a base model someone else trained, on data you've never seen, wired together with ML libraries, plugins, and infrastructure all pulled from somewhere else. And here's the uncomfortable part. A weakness anywhere down that chain quietly becomes your weakness. It's the same story as a vulnerable dependency in classic software. OWASP, A0X, just with much bigger, much stranger building blocks. So let's actually name what can go wrong along that chain. You might pull down a backdoored model, one that behaves perfectly until a hidden trigger flips it. You might inherit poison training data where bad behaviors are quietly baked in long before you ever fine-tune. You might grab a malicious model file, and this one bites because formats like Pickle can execute code the moment you load them. And of course, the classic, a vulnerable dependency, some library or plugin carrying a known CVE or a hidden payload. Remember, a download is not always just data. Let's zoom in on that last point because it surprises people. When you call torch.load on a pickle file, you're not just unpacking weights, you're leading that file run Python. So a malicious.bin from a random repo is effectively remote code execution dressed up as a model. The fix is boring but real. Prefer safe tensors, check the hashes, and only pull from sources you trust with a shell. This is just OWASP AOR6, vulnerable components, wearing an AI hat. So, how do you actually harden this? 4 habits. Pull models only from trusted hubs and verify checksums, same way you treat a signed package. Prefer safe formats like safe tensors over anything that executes on load. Pin and scan your dependencies for CVEs just like a normal app, and treat plugins as code, least privilege, and a real review of what they're allowed to touch. It's classic dependency hygiene, just extended to models, datasets, and plugins. Before we move on, let's clear up 3 myths that keep tripping people up. First, RAG doesn't make your AI safer. It grounds answers, sure, but every retrieval is fresh outside text flowing into the model, a brand new injection channel. Second, a model file isn't just data. Some formats execute code the moment you load them, so treat an untrusted model exactly like an untrusted binary. And third, open source isn't automatically safe. Open weights can still be backdoored or poisoned. Verify the source and the checksums every time. So with those myths out of the way, here's the shape of a hardened pipeline. On the do side, vet and sanitize anything you ingest, treat every retrieved chunk as untrusted input, stick to verified models in safe formats, and keep plugins scanned, end, and on least privilege. The avoid column is just the mirror. Indexing sources you can't vouch for, trusting retrieved docs like Scripture, pulling weights from random repos, or wiring in plugins with broad, unreviewed access. Same pipeline, 2 very different outcomes. Good news. You don't have to build this discipline from scratch. Safe Tensors gives you a model format that won't execute code on load. Checksums and signing let you prove a file is the one you think it is. Trivia and Gripe will scan your dependencies and container images for known issues. SBOM tooling inventories, what's actually inside your stack. Content sanitizers clean documents before they ever hit your index. And provenance tracking keeps a paper trail back to where the data came from. None of these are exotic. They're just the seatbelts for the pipeline we just drew. So let's pull the thread tight. RAG poisoning is really just prompt injection wearing a librarian's coat. The payload rides in on a document you chose to trust, and that trust is the real story here. You're building on borrowed models, borrowed data, borrowed libraries, and any one of them can carry code that runs the moment you load it. So treat retrieved content as untrusted, prefer safe formats like safe tensors, and verify, scan, pin, and least privilege everything in between. If you take away one rule from all of this, make it this one. Trust the source, not just the user. Every document your AI reads, every model you load, every dependency you pull, that's all part of your attack surface now. Blindly index, blindly load, and poison flows straight into your system, but vet the docs, verify the models, scan the depths, and the chain holds. And here's the thing. This episode doesn't stand alone. Poison docs, that's indirect prompt injection from episode 1, retrieval leaking the wrong context. That's the data leakage problem from episode 2. Vulnerable components? That's literally OWASP A06, just pointed at your model weights and your vector store. Supply chain security isn't new. RAG and base models just add new links to a chain you were already responsible for. So if you want to go deeper, the book, AI Security Explained, walks through this whole arc, prompt injection, data leakage, insecure outputs, the RAG and supply chain risks we just covered, and the next frontier, securing AI agents. And when you're ready to get hands-on with RAG pipelines and the model supply chain in a real environment, the AI LLM Security Mastery course over at Dargslan.com, AHA Courses, is built exactly for that. But before we wrap, I want to leave you with one honest question to sit with. Do you actually know every source feeding your AI, every document it retrieves, every base model it inherits from, every library quietly pulled into the stack? Do you trust all of them? Think about where a poisoned source could slip in unnoticed, and drop your answer in the comments. I read them. And that's a wrap on episode 4. We've locked down knowledge sources and components, but the real boss fight is next, securing full AI agents where models, tools, and data all collide in one autonomous loop. Hit subscribe so you don't miss it, and check out Dargslan.com for the deeper write-ups. Stay sharp out there.